So, hello everyone, welcome back to our channel. Today, we will continue our Verilog series, and the topic of the day is if-else construct. So, without further ado, let's begin. All of you must know what is what is simply meant by if-else statement. You or must have tried in C or any other language. Simply put, if-else is a type of conditional statement that controls the flow of execution based on evaluated expression. In Verilog, there are three types of conditional statement. First is if for simple conditions, then if else for binary condition, true false reason making, and the third one is the if else if for multiple condition branches. These are all parts of procedural statements and are used inside initial or always task or function block. Now, what are procedural statements? We will be having a deep discussion on it in further videos. For now, let's focus on the if else construct. So, the first statement is the if statement. What does if statement do? If statement evaluates a expression provided to it to a true value, and if it evaluates the value of the expression provided to it, and if the value comes out to be true, then the statement written inside the if block will be executed. What does a true value mean? A true value means a non-zero value. If an expression is false, that is, it's 0, x or z, then the statement is skipped. We can have a statement or null statement. If we want to write some statement, then we can write. And if we don't want any logic, we can just directly simply put a semicolon here. Then also it is valid. For multi-bit expression, this is very important. The entire expression is evaluated as true if even one of the bit is 1, that is non-zero and known. We will be taking a look at the example for this point. So this is a simple syntax of if statement. We have keyword if, then in the round brackets we write the expression whatever we want to evaluate, and then we write the statement. And what can be a part of expression? It can be a constant number, a variable, or any expression. All of these are allowed to be part of an expression. Let's take a look at the example. Here I want to write a condition that whenever A is greater than B, then the variable max should be set equal to variable A. Otherwise, max should remain unchanged. So for that, I should write like this. If A greater than B, then max should be equal to A. And here I put a semicolon. Semicolon is used to indicate that a statement has been completed, to terminate a statement. But instead, if I wrote the semicolon just after the condition, then that makes this if condition useless. That this is like a null condition, as we discussed earlier. It's not necessary that there is a statement. If you directly put the semicolon, this is also syntactically valid. Verilog won't give any error for this statement, but the aim which you want to achieve, that is, max should be equal to A only when A is greater than B. Then the condition which you wanted to achieve won't be achieved. Here, even if A is less than B, then also A will be provided to max. Hence, we need to make sure such syntax is such error we don't make while we are creating our logic. Now, the multi-bit example which I was talking about. I have this condition. If 2-bit be x1, then how will this be evaluated? As the rule says, if there is at least one bit is 1 in a multi-bit, then the entire expression is evaluated as true. All we have unknown x. Even then, this condition will be evaluated as true, and this will be executed, and this won't be the else part won't be executed. No bits are 1, so the entire expression evaluates as false. As in this case we have x and 0. Here no bits are 1, then the else part will be executed. As you looked in the previous example, if else statement. The if else statement adds the else keyword with the if statement. If the expression is true, then the first statement is executed, and the else part is executed when the expression is false. The main thing here is at a time only one branch can be executed. Both of the branch can never be executed in the case of if else statement. If the condition is true, then this part will be executed, statement, and if the condition is false, then else part will be executed. Let's take a look at this example. I have condition if A greater than B, then max is equal to A, or max is equal to B. That means whichever variable has the higher value, that will be assigned to A. For example, if value of A is 10 and B is 5, then 10 is greater than 5, yes. So the condition is true. Then 10 will be assigned to max. But if I swap the values, if A is 5 and B is 10, then is 5 greater than 10? No. Then else part will be executed and value of B will be assigned to max. This was an example of if-else statement. Now we can also have nested if-else statement. That is having if inside an if. This is called a nested if-else statement. Let's take a deep look at this example. I have a condition that if x greater than 0, then I check if a greater than b, y is equal to else y is equal to b. But here I don't specify for which if I am writing this else. So will this else match with the inner if or the outer if? Such conditions Verilog resolves by associating the else block with the closest if, that is missing an else block. Hence, here the else will be associated with this if block, that is if a greater than b, then y is equal to a, else y is equal to b. But what if I want to associate the else part with the original if block, if x greater than 0? For that, we will be using begin end statement. Now, what is begin end? Begin end simply groups multiple statement into a single block and allows them to be treated as one unit in a if condition. Here, if I write begin end, then this whole statement will come inside this if block and this else will be separated outside. Hence, this becomes one part and this becomes another part. So we have associated our else with the outer if. So this is a recommendation even when you write a single statement like this I have mentioned here, you should include begin end statement. If you write, you must have remember that in C we used to write curly braces. This begin end can be understood similar to that. Instead of writing curly braces after if and ending with else, we can simply write begin. Then before else we can write end. So that makes the whole part from begin till end part of the else. If and then after else also we can write begin end if we are having multiple statements. So simply begin end will be used to group multiple statements in a single block. We will be having further discussions on begin end and what are its other purpose, as you will be seeing begin end in various places in further videos. For now, I hope the intention of using begin end here is clear, and also the recommendation of using begin end with the if else construct. Now the third type what we are having is the if else if statement, that if we have multiple conditions, then how can we check them? Then we can use the if else if statement. The syntax would be like this. We write the first condition, if expression 1, then statement 1, else if we can write the expression 2, then statement 2, else if expression 3, then statement. Finally we have the else block. This will be executed when none of the if else if conditions are satisfied. So the conditions are evaluated in top down, as I explained, in sequence. As soon as a true condition is found, its block is executed and the rest will be skipped. That is, if my expression true becomes true and statement 2 will be executed, all the conditions below it won't even be checked. And the final else is optional, as even here. When we write if, it's not mandatory to write else, but it's always a recommendation that you write else. So that makes it easier to understand and maintain it in future. The final, if you don't have anything to write in the final else block, then you can have a default or error checking statement that for example, something like this. In this example, if you see, I have if else if change. If that checks the condition in order and assigns the first matching grade based on the value of marks. If the marks are greater than 90, then grade will be A, Else if the marks are greater than 80, then grade B. Else if the marks are greater than 70, then C. Else if 60. Now, if the marks are not greater than 60, and I only wanted to assign A, B, C, D, then also I can add a else block that the rest, all the marks we consider as the F grade. This is how we can use the multiple if-else statement. But keep in mind that these are always stacked from top to bottom. So priority will be always given to the first condition or the first. These are some special cases and best practices. Default case handling. That I mentioned earlier, always include a final else for error handling, even if it's just for debugging. That makes it easier for someone to understand for what a code was written. Then we block statements. We have to use begin end for multiple statements, and they are recommended even for single statement for clarity. Then exit handling, as you mentioned earlier, the x and z, if are they are in single bit, then that condition is deemed to be false. But if they occur with one, at least one bit one, then the whole condition will become true. So make sure if your condition expression is having x or z in it. And the priority logic. If else, if creates a priority encoded logic. First conditions will always have higher priority. So what to do? If I want to give equal priority to all the conditions, in that case, we will have to use the case construct. In our next video, we will be exploring what is case construct and how we can use it to achieve such scenarios while giving equal probability to all the conditions. I hope everything is clear in the if-else construct. Make sure to try out the codes which we have shown here. And if you have any queries, please feel free to reach out to us. We'll be happy to help you. Thank you for watching.